Welcome you all. Myself Nagarajan, Assistant Professor in EC Department, Rohini College of Engineering and Technology. In this lecture, let us see the embedded system and IoT subject for biomedical engineering. The topic is a embedded C and C++ programming. So let us see the definition of a embedded C and C++ programming. So it is nothing but it refers to the use of C and C++ programming language to write software that is directly executed on embedded system. So these languages are popular in embedded system design due to their efficiency, portability and direct control over hardware. Now let us consider the key features of a embedded C and C++. First key feature is here efficiency and speed. So embedded C and C++ allow for low-level memory manipulation and direct access to hardware registers. So it will be enabling the development of highly efficient code that can run on resource-constrained devices. And next key features is here portability. So portability means code written in embedded C++ can be easily ported across different microcontrollers and processor with minimal modification. So thanks to the standardized syntax and semantics of these languages. And next one is the extendability. So C++ will add object-oriented programming features like classes, inheritance, and polymorphism, which can be used to design more modular and scalable embedded software. And next, let us see the key components in embedded C and C++. First one is a data types and memory management. So embedded system often have specific constraints on data size and memory usage. So understanding the use of fixed width integer types and memory allocation technique is crucial. And next one is a pointers and direct memory access. So pointers allow direct access to memory address, which is essential for interacting with the hardware register and peripherals. So DMA controllers can be used to transfer data between memory and peripheral without involving the CPU. And next one is a interrupt handling. So interrupt handling means embedded C++ provide mechanism for handling interrupts which are essential for real-time system performance. Writing interrupt service routines in C++ allows the system to respond quickly to external events. And last one is a bitwise operation. So manipulating individual bits of data is common in embedded programming, particularly when configuring hardware registers or controlling peripherals. Bitwise operators are extensively used for these tasks. Now let us see the programming techniques in embedded C and C++. So first one is a polling with interrupts. Before that we define that is what is polling and what is interrupt. So polling means it is continuously check the status of a peripheral or flag in a loop until a specific condition is met. This technique is simple but can be insufficient as it consumes CPU cycle. So interrupt, next one is a interrupt. So interrupt means it configure peripheral to automatically trigger a function when a specific event is occurs. So polling means it continuously check the status of a peripheral. Interrupt means automatically trigger a function when a specific event occurs. Next one is a modular programming. So modular programming means it divides the software into independent modules, each responsible for a specific function. So such as a handling a peripheral or implementing a communication protocol. This approach improves code maintainability and reusability. Next one is a state machine. So state machines mean implementing control logic as a finite state machine where the system transition between the different state based on input event. This technique is useful for managing complex control flows and ensuring predictable behavior. So now let us see the embedded C++ development workflow. So first we needed to develop a code, then compilation, and then debugging, then optimization. Then after that we want to deploy the in the hardware. So code development. So code development means it is write the application code using an integrated development environment that supports embedded C and C++. Next, compilation and linking. Compile the code into machine code using a cross compiler specific to the target microcontroller. So the linker combines the compiled code with startup files, libraries, and memory allocation information to create the final executable. And next one is a debugging. So debugging tools like JTAG and SW interface to step through the code, set breakpoints, and inspect variables. So this process helps identify the resolve issues such as a memory corruption, timing errors, and incorrect peripheral configuration. And next one is a optimization. So optimization means if apply optimization technique to reduce the code size and improve execution speed. Deployment means flash the final executable onto the microcontroller memory using a programmer or debugger. Next one is a embedded C++ programming challenge. What are the challenges faced in when we designing a embedded and C++ programming? So first one is a resource constraints. So resource constraint embedded system typically have a limited memory or and processing power, requiring careful management of resources to ensure that the software runs efficiently and reliably. Next one is a real-time requirements. So real-time requirements means is meeting the real-time deadlines is crucial in many embedded applications. The software must be designed to respond to events within the strict timing constraint. Next one is a time debugging and testing. So debugging embedded system can be challenging due to the limited visibility into the system internal state. Now let us see the application of a embedded C and C++. So embedded C and C++ applications are consumer electronics, automotive system, industrial automation, and medical devices. So consumer electronics means in the embedded C++ is used in development of firmware for devices like smartphone, smart watches, and home automation system. In industrial automation, in industrial automation, embedded C++ is used to program PLC and other industrial control system. In an automated application system, the ABS and engine control units are developed using embedded C++. And next last one, it is a medical devices. So medical devices, embedded C++ is used in development of a life-saving medical devices such as a pacemaker, infusion pumps, and diagnostic equipments. I hope that all of you understood about the what is the need for a embedded C++ in the embedded product. So we define embedded what is embedded C and C++ and also key features and key concept of embedded code. What are the challenges we facing that when we develop a code. Thank you.